Hello, my name is Matt Hettermann, and I'm the VP of R&D for EUV Tech, and I'm here to give you a company and product overview. Our company was founded in 1997 in the San Francisco Bay Area here in California. We're a global leader in production of at-wavelength EUV metrology tools, with the majority of our offerings being first to market. We have solid long-term partnerships with all major semiconductor manufacturers, consortiums, research centers, and suppliers. You can see the pins dropping at our EUV tool installations worldwide in all the typical places you would expect EUV metrology tools to be showing up: the Americas, Europe, and Asia. We have a long-term partnership and collaboration with Lawrence Berkeley Lab and the Center for X-ray Optics. In fact, the company was spun out of CXRO 26 years ago to commercialize EUV reflectometry. And we've continued our tool development partnerships with CXRO and LBNL on our Aries EUV microscope and our brand new ENK phase tool. We also collaborate with them on advanced multilayer coatings, nano-diffractive optics, and unique coherent EUV metrologies. We are the recognized leader in EUV metrology solutions and a market leader in delivered at-wavelength EUV tools. EUV Tech has a long history in delivering tools to major semiconductor manufacturers worldwide. We set the benchmark for the strategic and rapid development of precision-built EUV tools. Here you can see the interior view during assembly and construction of our new EUV NK tool, and an exterior view once the tool was finished construction and undergoing qualification in our clean room here in California. We deliver fully automated production tools to all major semiconductor companies. They are SEMI S2, S8 certified. They can have RSP 200, MRSP, or customer specified frame or holder compatible front ends. We can be OHT and AGV compliant via SEMI E84, and we have full factory automation as an optional add-on, SexGem, and customer-specific protocols when needed. The tools meet EUV particle adder per pass requirements that are continually driving smaller and smaller, but we continue to meet the industry's needs in that space. I'm going to give an overview of a few of our biggest tools, starting off with our EUV HVM reflectometer. It measures the EUV reflectivity of masks. We are the world's market leader in manufacturing reflectometers. All EUV mask shops and EUV mask suppliers utilize our high-volume manufacturing reflectometer. It's a mature product with excellent uptime and full factory automation integration. You can see here a picture of the fully assembled tool on the right, and a typical reflectivity versus wavelength scan on a normal multi-layer mask there in the center. Here's an interior view of our HVM reflectometer. Here on the right, as I mentioned, you can RSP Smith pod, opener, dual pod is an option, MRSP is an option. Moves into an EFEM, ultra clean atmospheric handling robot that will then move the sample into a load lock here. Also ultra clean pump down to high vac, close to UHV. Core robot here in our vacuum transfer module takes the sample from the load lock and into the process chamber here, which has an XY stage to move the sample around. Our EUV LPP source is up here at the top. This was developed in-house. It's a laser produced plasma off of a copper reel-to-reel tape in this chamber here. EUV optics and a monochromator in this chamber here, down into a detector and slit chamber, and that projects approximately a 1 millimeter beam onto the sample down in the process chamber. Another major tool for us is the pellicle transmission measurement tool. It measures pellicle transmission and reflectivity across a user-specified wavelength range. Our pellicle transmission tool is the only tool in the world that has the repeatability, resolution, and speed to meet the needs of pellicle manufacturers. We demonstrated performance and stability paired with an ultra-clean transfer system. Very similar transfer system to what we use in our reflectometers. We've been delivering this pellicle transmission tool since early 2017. Here you see a data set from an early stage pellicle transmission map. The current pellicles are performing much better than this, but this is what I'm allowed to share publicly. Sample A, you can see, actually has good uniformity, especially for an alpha stage pellicle. Whereas sample B, you can see pinholes, the spikes going up in deep red here, where there were holes in the pellicle, and then also some kind of defect, a particle or a defect in the pellicle itself, where these divots are here and here. So this was exciting data. First of its kind, really. This taken on our pellicle transmission tool as we were developing it. ARES is our actinic image review system. It's an EUV microscope and can be used for defect printability review of EUV photomasks by capturing real-world mask defects. ARES drastically reduces the installation time as compared to other EUV actinic mask defect inspection systems and has a lower overall cost of ownership. ARES features EUV Tech's patented zone plate imaging system and incorporates a proven ultra-clean transfer system for transferring the mask to the process chamber. This allows the microscope to image the mask exactly as the scanner would see it during production. Our first ARES tool was delivered in 2020. Currently building our next generation ARES tool for delivery in Q1 of 2024. Here's some data from our ARES tool of CD uniformity measurement. This is 88 nanometer lines across a 3-micron field, and the CD uniformity here was plus or minus 1.3%. This was analyzed with our Summit software package, which is another one of our products that can be incorporated within our tools or sold separately as an analysis system for different semiconductor metrology analysis algorithms. Our plasma source-based N&K tool is our newest tool. It utilizes our proven high brightness and high stability EUV source. It interrogates the mask at angles of incidence from just above 0 to almost 90 degrees. The system automatically calculates N&K and other properties of the multi-layer stack. Automated transfer system supporting RSP200 pod is incorporated in this tool. Other front ends are certainly options if needed. It's a fully configurable software enabling automated data collection procedures with control over position, angle, and wavelength. The software supports automatic parameter extraction, and our first tool delivered in Q3 of 2022. Our second tool delivered in Q1 of 2023. We have more tools currently in construction with additional customer orders in the pipeline. Here's a rough picture of the interior of the tool. As I said, it uses a proprietary ultra-high brightness LPP source with a very flat spectral response. It has a broadband optical system, a programmable EUV spot size supporting down below 100 microns, and has a high resolution monochromator, higher resolution than the one in our reflectometer. You can see here the optical tables up top with a drive laser behind, some atmospheric optics, goes into a copper reel-to-reel tape chamber, into some EUV optics and monochromator in this chamber, and then the process chamber down here, much bigger than our reflectometer because it requires full rotation of the mask and full rotation of a detector around the mask for our multi-angle measurements. The initial driving application for this tool is the EUV mask film material characterization. We can determine the optical properties of EUV mask material at the actinic wavelength. direct measure of complex index of refraction, both absorption and phase, and can determine thin film characteristics such as thicknesses, composition, and interdiffusion. Can determine the multilayer stack information and measure thin film phase effects and true actinic phase. It's a commercial implementation of a proven technique. The method was developed at the Center for X-ray Optics at Berkeley Labs over the past 3 decades. And you can see here the solid line is the measured data, and the dotted line is the fitted data. Sigma is the roughness, and D is the thickness. So this is what we can do with our EUV multilayer parameter fitting capability. Can measure reflectance as a function of angle and wavelength. On the left is a typical multilayer mask without absorber. So you can see a beam coming in, similar, slightly attenuated beam coming out. And here you can see the different angles versus wavelengths and the reflectance at each of those pairs. On the right is a similar setup, but with an absorber stack on top. So you can see the same size signal coming in, much more attenuated signal coming out, and you can see definitely some phase effects and interesting characteristics in the center of this graph here, which is also angle versus wavelength versus intensity. So what can we do for EUV reflectometry and scatterometry? So the reflectometry has a source with a variable wavelength and angle of illumination, and a detector. So it's plane wave in and plane wave out, and the detector stays at theta 2 theta of the illumination angle. In scatterometry, on the other hand, the source, we have a variable wavelength and angle of illumination, comes in and hits a grating, but the detector is actually moved for every wavelength and angle of illumination, moved through the various orders to record the scattering of light off of, in this case, a grating on a mask. So it's a plane wave in and diffracted waves out. There's 3 types of actinic measurements currently on the E&K tool. The first is just a simple material N and K, and that's typically what we start with. Pure materials, popping out the N and K parameters. Typically those run from 40 to 86 degree angle sweeps with a fixed wavelength. So grazing incidence and is very surface sensitive. The second thing we can do currently is a relative phase. So that can tell you the relative phase difference between a multilayer and a multilayer with an absorber. And typically those scans are run at angles from 2 to 10 degrees and wavelengths from 12.5 to 14.5. They need to be close to the multilayer peak to extract the right information. And finally, a pattern phase in the near field off a grating. Again, angles from 2 to 10 degrees and wavelengths from 13.3 to 13.7, so very close, like pretty much right around the peak of the multilayer to get the highest signals on the scattering. Here's a scatterometry data on a pitch 160 50% duty cycle sample, and you can see the different diffraction orders noted here. The blue line is an attenuated phase shift mask, and the orange line is a more standard tantalum nitride mask. You can see the APSM mask has 0 order suppression while enhancing the scattering in on the higher orders. And also both absorbers show mass 3D effects where the negative diffraction orders are bigger than the positive diffraction orders. In conclusion, our HVM reflectometer has a long history of measuring and qualifying masks at multiple steps in the mask creation and utilization process. The pellicle transmission measurement tool is used to qualify pellicles and prove out new pellicle materials. The Aries microscope is a low-cost leader in review of actinic defect printability. And the EUV NNK tool, while able to measure standard NNK, is the premier tool for accurately developing and qualifying APSM masks, and also has multiple scatterometry applications. Thank you for your time. I hope you enjoyed it, and if you have any questions, you can visit our website and at euvtech.com. There's contact info there, and we look forward to hearing from you. Thank you.